We'd like to introduce the LED light that maximizes melatonin suppression. With Samsung's advanced technology, our energizing lighting solution could change the way you spend your day. Light is the most influential factor in the environment that affects the sleep-wake cycle of humans and the entire living world. There are many types of research on the awakening effect of light that energizes the human body to stay alert and work, study, and do many other activities. The awakening effect of light comes from the short wavelength of the visible spectrum that suppresses melatonin production. The action spectrum comes from the intrinsically photosensitive retinal ganglion cells, iPRGCs, photosensitivity centered around 480 nanometers, which is the cyan region of light. This has been proven through nocturnal melatonin suppression experiments and by anatomical studies of retinal photoreceptor cells. It is interesting to note that this is the color of the sky during the day. Therefore, designing a light spectrum that gives more spectral power density around the 480 nanometer region at a given brightness is the key to creating energizing light. Energizing lighting must have a high circadian stimulus. However, when it comes to practical lighting installations, just having a high circadian stimulus is never enough. The fundamental requirements of LEDs, such as high efficacy, long lifetime, good color quality, and eye safety, should also be satisfied. Additionally, it would be great to have various correlated color temperature (CCT) options for freedom in lighting design. Here's Samsung's choice of technology for the best energizing lighting solution. LM302N Day is built with dual blue dyes, one at the conventional 450 nanometers and the other at 480 nanometers. We made them into the popular 3030 form factor. We'll look into the details of why this is the best energizing spectrum that also fulfills the requirements of practical lighting. The addition of the long wavelength blue peak directly increases the melanopic to photopic ratio of the spectrum by 20 to 30% when compared with conventional white LEDs. The resulting benefit is a 23% increased melanopic daylight equivalent illuminance, MDEI, at the same illuminance as conventional LEDs. In other words, you still experience the same MDEI, or energizing effect, even though you're under lighting with 19% lower brightness. Let's compare LM302N Day with other potentially good candidates for daylight circadian lighting LEDs. Here, I overlapped the spectral power distribution of three different types of LEDs together with the photopic sensitivity, melanopic sensitivity, and blue light hazard functions. The first LED, LM302N Day, has double peaks in the blue region. The second dye peaks at 480 nanometers. Company A uses a near UV dye to pump phosphors that evenly cover the whole visible spectrum. Company B utilizes a conventional blue dye, but augments the cyan range by using an additional short wavelength green phosphor. Starting from the melanopic to photopic ratio, you can easily recognize that LM302N Day performs best thanks to its prominent cyan peak. What about efficacy? Company B's LED had minimal tuning to the conventional high-efficacy white LED spectrum, so it wins there. The LM302N Day is supposed to exhibit some efficacy penalty due to the high indium concentration of the indium gallium nitride materials in the chip. Company B is worst in efficacy, mainly because of the big difference of the pump wavelength and the emission wavelengths of the phosphors, and because it has a wider spectral distribution outside the photopic sensitivity curve. For lifetime, the first and third types of LEDs won't have much difference, although the LM302N Day has some advantage thanks to its longer wavelength cyan emission. However, the second approach would suffer from faster degradation of packaging materials due to the high-energy photons emitted by the near UV dye. In terms of color rendering index, CRI, or the color quality, Company A is the best. However, the blue light hazard, weighted and integrated by the blue light hazard function, exhibits the highest value with the second type of LED. How about the first and third types of LED? These two exhibit less blue light hazard when compared to a conventional white LED at the same correlated color temperature, CCT, and CRI. Our product successfully creates a better environment and helps enhance concentration. It can be used in various applications. For example, it can enhance learning ability in schools, improve work output at the office, and increase productivity at the factory. A great thing about Samsung's LM302N Day is that the product lineup encompasses a wide variety of CCT options, from 3000 Kelvin to 6500 Kelvin. Imagine a 4000 Kelvin standard CCT light created with LM302N Day for office spaces. It gives the same melatonin suppression of a 5700 Kelvin cool white conventional LED light, which is avoided for its unpleasant coldness. Or a 3000 Kelvin cozy warm light that is as awakening as conventional 4000 Kelvin lighting. This is all a subconscious effect that only your autonomous nervous system recognizes. We performed a series of clinical tests with a university in Korea to investigate the effectiveness of the circadian lighting spectra that we created. We recruited 30 male subjects aged from 20 to 50 and had the individuals spend 2 trial periods of 3 days and 2 nights in the specially designed rooms with either circadian or conventional lighting environments on the first trial, and a week later with the other type of lighting in the second trial, in random order. They could read, work, and exercise during their stay, while the researchers took measurements including electroencephalogram, heart rate, body temperature, and salivary melatonin level by the hour. And at the end of the day, they were put on the D2 test, which is the standardized concentration level test. They also solved some Sudoku puzzles for the estimation of their performance. So here's the result of the average melatonin levels of the subjects under 2 different lighting conditions. As you can see here, the melatonin level under LM302N daylight was more strongly suppressed compared to the conventional lighting by 18%. On the third day, the subjects retook the D2 test, and they also solved some Sudoku puzzles. Remember that they each took 2 sets of tests, once under conventional lighting and once under the LM302N day. The type of lighting was randomly chosen so that the score would not be affected. From the test, better scores were shown both on the D2 test and Sudoku test under the lighting with LM302N day when compared to conventional lighting. Samsung's LM302N Day is offered in 3030 EMC packages with CCT options from 3000 Kelvin to 6500 Kelvin. The corresponding typical melanopic to photopic ratios are shown on the chart. Thank you.